Hello, in this video we'll demonstrate how to use model simulation together with the product line engineering capability to manage the variance and filter the model from 150% reference architecture to the specific one, which would be executable based on the selected features in the feature model. For the demonstration, we'll use automatic headlight system. There's another video with this model simulation overview. And this model has a controller, light sensor, headlight, and switch. So the logic is pretty much that we can switch lights on, off, or we can switch to auto. Then based on the ambient temperature, based on the requirements and the logic in the model, it automatically switches on and off with some delay. We have in the model requirements, we describe the on, off mode, and especially automatic mode with all the percentages of the ambient light. We have use cases, so we have on, off, auto, and then calculate headlight state, calculate hysteresis. So no. We have context, where is your system, driver, ambient lights, and power system, what flows in and out. We have system internal block diagram, where we have switch, which connects to the controller, which provides status of the switch off, on, or auto. Controller, if in auto mode, switches on ambient light sensor, and ambient light sensor passes the light intensity. If it is in on mode, it does not use the light sensor, and then switches light on and off. If in auto mode, so light is automatically switched on and off by this part of the controller. Also, we have user interface like off, on, auto. Then we have ambient light intensity we can change, and we have visually lights on and off. So we create a simplified user interface to be able to use sometimes this one based on the user choice and the feature model. Then we have simulation configs, but that's like some internal information. And then we are creating a feature model, as you can see here, very simple feature model using the model-based product line engineering capability. We have the class diagram root feature. We have dynamic light and user interface groups, where we have just two features, pretty much automatic, true, false. So if it is true, then we have automatic mode. If false, we don't have automatic mode. And advanced UI, if it's true, we have advanced UI, as you can see here, this one. If it's false, we have the simple UI. So we have any combination with which we capture in the instance model. So now when we execute this model, as you can see here, it runs, for example, slow execution runs. And we have both user interfaces. So this is like 150% architecture. We can capture system execution. You can see that execution here. We can switch on. You see, like, it sends the signal on. That switches the lights on. Lights on, you see, and then that will switch lights on. You see, headlights on, both user interfaces. I can switch off. Sends the signal off. Also, I can see, you know, the sensor, light sensor is off. I can switch to auto. And if I switch to auto, signal with the auto goes in, and then we activate the ambient light sensor, and that is simulating this model. So now what it comes to the product line engineering, we have this MBPLE product line engineering plugin installed, which is no cost here. Resource plugin manager. Here we have product line engineering plugin, and we can actually, based on that, see this interface here automatically showing the instances of the feature model, and then we can filter. So if we have automatic with simple UI, so we have this one available because it's automatic, right? This one available. If we go to other diagrams, pretty much everything what is needed is available. Now, if there is automatic with advanced UI, still everything same, you know, light sensor, those properties, you know, those requirements, those use cases. It takes a couple of seconds to refresh, but we'll see that refresh. Here we have this use case modified, as you can see here. And we have this part available, then non-automatic with advanced UI. So then this part does not exist. This also does not exist, this part, if we'll go here. we'll soon see that this part will not exist, non-automatic with UI. Yeah, here you go. So, and then non-automatic with simple UI, same, just the UI is different. So because it's simple UI, so this one exists, this does not exist. And in this case, with advanced UI, this exists, this does not exist, and even this exists, as you see, like non-automatic. So this will disappear, this will disappear, this will disappear. So here we have the highlight what would happen if we will realize this variant of the reference architecture. So to have specific configuration as we selected here in instance model. So we can choose whatever we want here. Also, we can see that there is requirement which talks like that the headlights feature shall support the following modes: off, on, and auto. So this auto mode is actually filtered based on the choice here. This or this, right? Auto or no auto. But this one gets modified, so it will have off, on, or it will have off, on, auto. So now let's check how that works with the transformation and then simulation after. So model transformation, variant realization, choose requirements, choose use cases, choose interactions, choose structure, choose user interface. So that's what we want to transform. This is our model, system model. And here we will pick the variant non-automatic. And let's choose like maybe not simple UI, but we can choose, for example, non-automatic, but advanced UI, right? We'll see how that looks like. Clear variants, no. For forcibly delete, modify read only, no. Finish, and we got requirements. As you can see here, this requirement is off, on. No longer it talks about auto mode. So here we have light sensor disappeared, properties related to light intensity disappeared. From the use cases, we see requirements related to auto mode gone. This part gone, related to ambient light. This comment is not gone, even it's related to ambient light, but we forgot to include that into variant realization. Then controller is much simplified, and the whole system is much simplified. As you can see here, switch does not have auto mode, controller does not have auto mode, controller does not have interfaces for light sensor does not exist at all, and we have same part here. And now from user interface, you see this user interface is really simplified. No preview, so we have no auto mode. We forgot to remove this part, so it could be removed, and we don't have ambient light part. Now from this perspective, all the same, and now we can actually execute this model and see that it works or not. So let's choose slow execution and run. You see we just get one user interface, and this is because another user interface is removed. Now we can switch on. We get on signal going. This actually is acting correctly, switches off or on, and then it's updating lights, and now we switch off. As you can see, what we have here, ability to choose the variant, simulation based on which we will filter system model, and we'll simulate the same model to check that it works as expected, that no properties are missing, that don't have errors in the command line, to see that everything is working as expected. Yeah, so now in the second part of this, actually we could undo here. Now what we can do, we can realize another variant. So go to tools and choose actually the variant which we want to, simple UI, non-automatic simple UI here, right? And go to the tools, model transformation, this one next, choose those sources for the system model. Next, as you can see, this one is no longer suitable. We need simple UI, not UI, but configuration. Simple UI, okay, and finish. So we are filtering, we are getting the same result, but now user interface is different. It's actually this simple user interface. Now let's, and as you can see here, this was still included, so we need to actually filter that, and let's execute the model. So run the model. We have simple UI. We have no errors. We can switch on, and then we will see that headlights are on. And that's the most simple UI which we can create to see everything in single place. Here you have on. We can actually switch that, but this is just like read only. And off. And off similar goes here. So now in the second part of this video, what we are going to do, we are going to recreate this whole product line engineering setup from scratch. So let's close this model as a final. We have the same model, just without feature model and variance configuration and variance variation point setup. Okay, so now what you have here, talking from scratch, so we will talk about that. You need to use this no-cost plugin, Product Line Engineering. It comes as a resource, let us know if you want that. It is available online, but also you can kind of ask us where to get that. And then you need to use this model-based product line engineering profile. So go to profiles, you will find this MBPLE profile. So use that. Once you use that, you can actually go here to create an MBPLE package, feature model. That could be even separate project using this. When later it will use, this feature model, your product model. And here we will create class diagram for feature model. Class diagram. And in that class diagram, we'll create, you see, root feature group. Vehicle, actually, not the vehicle. We will use this. Let's use this name for this one. Here, automatic headline system. And we'll have a couple of groups. You can just put a Boolean features, but I will put like UI feature, and then another one will be dynamic light. So I will type here dynamic light. Then if I want to make them as a group, so then just create a UI group. Oh, actually, not like that. Feature group, UI, and then feature group will be dynamic lights, and then use them as a type for those guys, and then we can just drag them and see how that relates. Why we do that, we want to see those as a separate groups in the feature model. We want to group our features. If you have 3,000 features, this is like something what you would want to do. Then here we will create feature. It will be automatic and type Boolean. So as a result of that, if this one selected, so we want that everything related to automatic would exist. If this is not selected, actually it should be here. It would, this do not exist. And then for UI, we want to create, advanced UI Boolean. And again, if that is selected, advanced UI selected, so we show advanced UI. If not selected, then we have simple UI. So with the UI, first of all, let's do with the UI. So it is very simple here with the UI. We'll see how that works. So let's go to the UI, and we have two UIs, right? So just one is needed. So right click for this one, first of all, and actually this one is advanced. So right click on this one, go to variance modeling existence. There are some different types of variance you can use. Like for example, if you want to change property value, you use primitive property. If you want tag value, like stereotyped property like a requirement within text, it would be primitive tag. If you want to change like property which is like points to another element, like owner, for example, you use like element property or element tag. But in this case, we use existence, and we have feature navigation. So we navigate to which feature we want. So it will be advanced UI here, and then close this dialog. And here we have advanced UI. And in this case, not is false. That's it. We are done. So this one will be visible when advanced UI is selected. And now for this one, we'll assign the same guy, variance modeling, actually new existence, in order to reverse it. So we have here advanced UI, okay, advanced UI, okay, and then close. And then here we have it true, not true, right? So it means that when it's not, it will be included, right? So it is this one included when it's true, this one is included when it's false. And now let's create a variance configuration variance config package for the feature model configurations. Let's create a diagram first of all, instance table here, like that, and then let's assign the headlight system as a classifier. For the, this is not the system, this is feature model, and then scope will be variance configuration. Then we'll show the columns which we want to see here, select columns. This will be advanced UI and automatic. So here we have automatic, here we have advanced UI, and then let's create configurations. Let's create 4 of them. Those configurations will be automatic, so will be automatic simple UI, automatic advanced UI, non-automatic simple UI, and automatic advanced UI. And maybe the opposite, like this. And actually, once I will name automatic advanced UI, automatic simple UI, non-automatic advanced UI, non-automatic simple UI. So we have all the possible configurations, and we have UI with the assigned variance variation points, so we can actually see how that looks like. Automatic simple UI, so this UI will be visible. Automatic advanced UI, this UI will be visible. Non-automatic simple UI, advanced UI, this UI will be visible, and non-automatic simple UI, this will. So it works. And if a simulation config, we put both UIs here, so only one will stay after filtering, so we'll have right UI available. Okay, so that's done. So now the next step will be to actually link the configuration parts of the model to the advanced automatic or non-automatic. So for example, let's start from here. So this one should be linked to automatic, right? So it is like switch. So right click, variance modeling, existence, and you see immediately it reacts, add, go here, and then automatic Boolean, select, okay, all done, close. Here we have this one, non-false, close. So if it is non-automatic, it disappears. Automatic, it is here. So now if we want to add to the same pool everything else which is required, so that, for example, this one is required, and then some other things are required. So for example, like this part, this one, interfaces, and so on, many other things, even requirements. So we need to do that from every of those parts. So we can do that updating the same variation point. We can go here, right click, variance modeling, existence, this same one right here below, and then here constraint elements. So this constraint elements pool we can use for example, requirements. So we don't need all of them. Actually, we need all of them only when we have this automatic mode. So this mode auto, then use cases. So for the use cases, let's see. So we have calculate target headlight state, conduct hysteresis, measure ambient light, set the headlights to automatic, set target headlight state. All of them are related to automatic, and then ambient light is also for the automatic. And let's switch to the whole properties instead of only an element, instead of only the types and packages. So also here ambient light is not needed as a part. Include here. Then what else? Interfaces, user interfaces, auto mode signal is not needed. External interactions, electric energy, light energy, yeah, we don't need that. System sensor on, not needed. Sensor off, not needed. Lights intensity, not needed. Structure now, this is very important. For example, we can even exclude intensity as a type here. And then controller has set state to the default and stop the sensor, not needed. Initialize the state and start the sensor, not needed. Then light switch position, like ambient light intensity, not needed. Lights intensity range low, lights intensity range upper. Then sensor control, not needed. Sensor data, not needed. And then states available. Auto, not needed. So as you can see here, all related things to that state, for example, all transitions coming in, out, will disappear automatically. So this cut is very smart, it is actually not harming the model, So now here we have a UI, which is simple. So simple UI is just a basic. More advanced UI is this one. So let's say light sensor not needed. Light switch is needed, but it will not have auto mode. Then headlight controller, it's okay. Ambient light intensity not needed. So all those things are gone, And what else? I think it is we are good, we are good on that, I remember that we had some problems with this. So let's see. So we have automatic advanced UI, non-automatic. You see those disappears things, but what about this part? So we can actually switch here now and then select this guy and select this guy and then even select this guy to be sure. Right click, go to the selecting Containment Tree. And maybe this is not the only thing here. So right click, selecting Containment Tree. Yes, so this one should be included into the, should not be included into the, because we want to see this one, but this one selected. Oh, this one is just a symbol. Okay, so it will stay. Okay, that's good. And now the last part is actually requirement. So we can actually, before that, see how that works. Will it work correctly? So for example, for this one, we can switch non-automatic. This will disappear. This will be modified. It will not have auto. Then switch here. So let's switch to this mode. So you can see this will disappear. But this one, so ambient light sensor, I think we haven't included. So yeah, ambient light sensor is not yet included. So let's go to any place where we have the same variation point. We go to variance modeling, existence. You see this list of the things, and now we'll eliminate that in the structure headlight sensor. Not only that we eliminate this guy, but also we want to eliminate in system part headlights ambient light sensor, that we would not have that one also. So here we have this one already eliminated. Then the last thing what we want is actually requirement. So this requirement should be modified. It is not the same for different situations. So we could have two requirements and then one appears, another disappears, you saw, but we could actually just use one requirement and then modify the text. So in that case, we have right click, selecting containment tree here, this requirement, right click, variance modeling, primitive property, primitive tag. Why it's primitive? Because the type is not the element, it is text, string, and tag because it's coming from stereotypes, requirement stereotype extending QML class. And let's go here. Let's choose the tag, which is text, stereotype tag, which is text. And feature impact, let's go do the feature impact. So it will be MBPLE, feature model, and that will be dynamic lights, automatic plus. Yes, okay, so we have this feature impact, close, and false. And now let's go here and then expression. So for the expression, we will use this expression. Just a second. We'll get this JavaScript and we'll use like that. You know, you could use like automatic value 1, value 2, or you can use like this, like if automatic, you can then put the any text, but if you need new line, then this one. If you need that string continuous on the next line, then you need this one. As you see, new line, then string continuous to next line. If it is only one line, then you just need those brackets, that's it. Else, so if automatic true, then show this text, like auto. If else, then show this one. That's it. So we are done with that. And you'll see here is yellow because it is actually modified. So now we could actually run this model and transform based on selected variant configuration and see it works or not. You know, so let's do that. Tools, model transformation, variant, next, choose requirements, use cases, interactions, and structure and UI. The last one is UI. Next, and then here configuration. So we'll use the advanced, let's say advanced non-automatic advanced UI because that's like the most interesting. And that's it. Finish. And here we have correctly, right? No non-automatic requirements are here. This requirement got modified. Then UI here, you see like we just got rid of the parts which we don't want. Then here we have no light sensor nor properties. Here we have no ambient light in the context of the system. And then we have no automatic mode in the switch. We have no interfaces to the sensor, no automatic mode in the controller. And we can now test that it works correctly. So with the fast, for example, execution, let's do that fast execution, see how that works. Okay. And we have this one on, all working, off, all working, no errors. We can see that in the trace of execution. Okay, so thank you. That was the demonstration how we can use the same model for different features configuration together with model-based PLE and simulation to validate that, including requirements and so on. And for the model-based PLE tutorial, take a look at another sample. For this model overview, take a look and also on another video. You know, we'll have the links in the description. Thank you so much.